Hello everyone, thank you for joining us and welcome to the second session of the Sealed Rooms webinar. My name is Stephen Stott and I'm a product specialist at XLR Systems along with my valued colleague here, Shelby, Hanson. Together we're here to give you the information you need to turn your dream into a reality with total environmental control technology for a greater understanding of planning, creating, building, and operating your next generation facility. Today in part 2 we'll be covering the fundamentals of temperature, humidity, air quality, and airflow design. First, we would just like to provide you with a quick refresher on who we are and what we do here at XLR Systems. During our past 15 years in business, we've deployed over 3,500 uniquely engineered mission-critical air systems to facilities across North America, encountering many different types of operational designs, from densely utilized spaces to extremely large buildings throughout all phases of development. Beyond internally designing and manufacturing our systems with industry-leading components, we also offer free consulting services and an unmatched level of customer resources and technical support. We're completely vertically integrated, allowing us to take care of everything in-house, provide insight and make modifications, and transparently inform you of any challenges while remaining true to your vision. We make it a big priority to empower you with what you need to be successful, to build trust and ultimately a mutually beneficial business relationship. We recognize the importance of casting a wide net across the industry by maintaining a close working relationship with professionals in all sectors. This allows us to gain a comprehensive understanding of everyone's individual needs. At XLR Systems, our motto is taking complex things and making them simple, which we see as the very essence of innovation. The potential usefulness of a new idea is severely limited if it's not integrated to make your life easier. So we strive for innovation that allows you to allocate more time to other issues. Building a business can be challenging, but if you get it right, it can be very profitable, especially in the cannabis industry. For that reason, beyond just supplying the equipment, we also understand the concepts and logistics of what you're trying to achieve to better help you meet your goals. We look forward to the opportunity to work with everybody because regardless of what part of the industry you're in, a relationship with XLR Systems is extremely beneficial. With the size and scope of the indoor agriculture sector having grown exponentially in recent years, we've recognized the growing need for greater resources on environmental control technology, especially in such a close-guarded industry. With the Sealed Rooms webinar, we're hoping to impart you with 15 years and thousands of systems worth of experience in just 3 insightful sessions. With that established, we want to begin with a brief recap of the previous webinar as it pertained to the facility and room. In terms of the facility and room itself, once you've selected a site, you choose to go with either new construction or a retrofit by evaluating the pros and cons between them. With new construction, it's going to take longer and cost more, but there's a lot more versatility. With a retrofit, working within an old, previously existing building is going to be cheaper and faster, but you have to decide what you're doing and how. Then you can look at a facility layout and power availability, which are intertwined factors, as they ideally determine the amount of lights and air conditioning that can be physically put in the space. Based on that, you decide to go with LEDs or HPS lights, and that layout will affect where the placement of the gear is. Once you know what gear you're putting in place, we can look at different ducting, which we're going to cover in today's webinar, and the growing method itself, be it open space, vertical, or container. Putting everything together, we then look at delivery, installation, and everything in between. Placement and design. What do we mean by placement and design? Further education on who, what, when, where, and why of unit placement within a room. As noted, the method you choose dictates room layout for plants, which dictates the lighting, which then dictates the heat load, based on how much power we can divide into each room. When looking specifically at bloom rooms, this determines how many plants are going to go underneath the lights. All of it is highly variable, depending on the plant strain and duration, where you could have 6 to 8 week plant be less than 2 feet in height, compared to a 10 to 12 week or even longer plant that can grow considerably taller. That's going to start to push back on how high the lighting is going to need to be in order for it to still be spread evenly. As this scenario illustrates, everything is intertwined. Therefore, even these differences in plant height are going to affect the setup of air placement, dictating how we can get return air back to the system, how the supply air is going to feed the room. This is particularly important in the case of the latter because we don't want to blow air on a shade that is going to redirect that air elsewhere. We want nice, clear paths. Again, this is going to be variable, with each specific setup relative to the scope of what you're able to achieve. Once we have established a general layout of how many plants, what size, light placement, and space available for ducting, be it down the middle of the room or only on one side, we can look at gear placement. Due to their sleek design and slim profile, our Evolution Series units are the most compact air systems on the market, with general dimensions of roughly 30 inches wide by 48 inches tall by 25 inches deep for the vertical offering. In determining the placement of the physical air handler, while there are pros and cons to both, inside and the outside options, we generally recommend that it be inside the room. The reason for this lies with the simplicity of the solution. On average, we already have multiple systems in each room, which at face value may make an outside air handler placement sound simpler. But when you look at the drawbacks of doing that, it's actually more challenging. When the system is outside the room, you need ducting to carry both the return air and the supply air in and out of the space, which depending on where the unit is held can be large and cumbersome, and needs to be insulated. You also need to get the airflow evenly throughout the space, while the units themselves have to be easily accessible for necessary filter changes and general maintenance. If they're tucked away somewhere that's extremely challenging to get to, maintenance is going to be done very rarely, if ever, and swapping components or systems could prove extremely frustrating in the event of a worst-case scenario. Additionally, depending on the construction of the facility, we've known some people who are literally cutting multiple square-foot holes through concrete, which is not an easy task. This challenging endeavor is worsened by the fact that we're moving more than twice the air of a traditional system, making those air turns quite prevalent, and it's not like we're just ducting one system. Because we're ducting 3 or 4 systems in general, some people have also wanted to put them all in one easily accessible area, perhaps closest to the mechanical room. This poses the challenge of having ductwork go back 50 feet the other way for both return and supply air, with the added time and money and resources accompanying it. With a massive network of ducting above, this simplified solution has become quite complex with gear everywhere. Then, load management means engineering weight loading on one portion of the room to support thousands of pounds at that point, depending on the ducting and how many systems are in one place, and that's just from an installation standpoint. In contrast, if the unit is placed inside the space, yes, it's going to take up some headroom, and if it's a vertical system, some floor space, but designing around that will be tremendously beneficial. Most of our systems are installed horizontally, with vertical units traditionally reserved for tighter spaces, where it's harder to hang something, like shipping containers or a multi-rack area. Vertical systems are much easier to work on, making installation a lot faster, especially in these setups, as they can be wheeled in with a hand truck, positioned in place, and vertically stacked. In the event that they need to be removed or for conducting routine maintenance, they are quite convenient and right there at the level for direct access. Filter changes can be done by anyone without the need of a ladder, and if there is a concern, the panel can simply be popped off. Usually the lighting system is close to the ceiling, with the lighting grid right below, and air system units evenly placed beneath. For example, if you have a room that requires 4 systems, it's best to think of them in quadrants, with a system in each quadrant for balanced airflow. In terms of CFM, cubic feet per minute, we have similar amounts in each, so that one system's not going to pull more than it's giving. We recognize that in certain room layouts, units have to be put to one side, but we try to make everything as symmetrical as possible. Notably, this is also done without the need for extensive additional components. All that's required for this configuration is some method of hanging the system. We offer wall brackets, but you can essentially construct anything that you want. Having these multiple systems hanging also makes installation very easy, especially for large-scale projects. As we previously touched on, once you've set one up and figured it out, the rest of them are going to be positioned somewhat similarly throughout the space. So your installation time is going to become quicker and more efficient. Built-in quick connect plug-and-play fittings and add-ons like pre-charged flexible line sets gives you a lot more versatility. Assuming that the systems are easily accessible by ladder or lift, filter changes and maintenance are not an issue. They're right there. And as you're going to be in that room every day, you can see if the filter is getting dirty and monitor them for any other issues, as opposed to having them stored away in another area that may not be checked as frequently. Another thing we definitely keep in mind is that in the event of an issue, you need to have a contingency plan to be able to work on, remove, or replace the system. This includes the potential to either access it with a lift or deconstruct the area fairly quickly. Anticipating worst case scenarios with a prepared backup plan is a smart way to approach any business, as problems always seem to arise at the most inopportune times. This setup is also much more convenient because we're dealing with a somewhat open ceiling grid, where we have balanced ductwork below. While being mindful of the lighting and other equipment, ideally you're running the ducting right down the middle to ensure that the air is dispersed as evenly as possible throughout the space, preventing hot and cold spots. If not, then you're running it to one side or teeing it off. With regards to ducting placement, each method of growing that we've mentioned is going to have different room design to consider as a starting point. For instance, in open rooms, we generally look to have center aisles as noted, and ductwork with air flowing down at angles of 4 o'clock and 8 o'clock. Above all, our number one priority when running ducting is achieving the best type of airflow design. Airflow design is probably the most important thing you can do for your room because it's going to dictate how well your temperature and humidity are maintained. And on the air quality side, how that air is coming back, getting filtered and treated with UV. It all comes down to airflow. If you're only able to attack a certain region with one area getting 80% more air than the other, it's only really working in that section. So airflow design is going to make a world of difference. When we talk about airflow, we're talking about return and supply air. The return air is the warmer air that's coming back to the system from the room. It's going past the pre-filter, past the conditioning coil, past the dehumidification coil, and then as the fan is going with heat transfer, the humidity is now removed, and it's going back through the space as the conditioned supply air. This happens continuously. Our rule of thumb is that we want the air turned over every 1 to 3 minutes, which is substantially more than the 10 to 15 minute cycle of traditional systems. This means we have a heightened ability to scrub, clean, and disinfect the air while removing moisture more frequently and mitigating hot and cold spots. There are many methods of air dispersion. Many people assume that they want to have the smallest ducts possible for their space constraints. This sounds like it makes sense initially, but when you restrict the air like that, you're putting more pressure on the fan, resulting in static pressure. Every fan has a curve to inform what its performance will be at a certain static pressure. Traditional HVAC systems use a squirrel cage fan design, featuring a round cylinder with multiple metal legs, which while decent at moving air is not optimal in high static environments. In contrast, our Evolution series systems are fitted with a backward incline fan, which moves air more efficiently by throwing it and is constructed from metal-infused plastic composite material, rendering it impervious to rust. Therefore, sizing your ductwork appropriately to handle the static pressure is critically important to ensure that it's moving enough air to prevent freezing the coil. Otherwise, with the coil freezing, air is not being turned over in the room, worsening the situation and making the system prone to freezing even faster, as less air is going through. Conversely, if you use ducting that's too large, the air will be much quieter because there's not as much restriction, but you won't get the velocity, inadvertently nullifying an integral aspect of what most growers are actively trying to achieve. That being said, a big part of this intent stems from their desire to feel the airflow. But in reality, you shouldn't be able to feel it, as it should be the same throughout the room from one end to the other. This misunderstanding ties in with the fact that many growers are rightfully aiming to get their plants to do a bit of a sway, to strengthen the stems and promote root growth. While attempting to replicate the natural conditions of a constant breeze is certainly advantageous, we highly suggest that the air conditioning system not be the channel that's utilized for this purpose. Instead, we strongly recommend using some sort of separate oscillating fans with more settings tailored to this specific task, allowing for targeted localization. After all, when they're small plants, there's a big difference in the kind of airflow required compared to once they've grown larger. It's important to keep in mind, though, that creating an erratic hurricane effect with fans pointing in different directions is not desirable, but rather spinning in a similar path that's more consistent with the ducting. When it comes to traditional ductwork, many HVAC mechanics like to run square or rounded ducting, and every so many feet place a T with a register for air to come out. The problem there is that with so much metal in the way, most registers have high static pressure. There's a substantial gap between each one. While you could certainly feel the airflow when standing right in front of a register, moving just 5 feet to the left or right would demonstrate the drastic difference with no discernible air movement. This localized jet stream approach is not desirable. Optimally, we want to get to a place where you don't really feel it because it's such even dispersion, with as many air turns as possible. Looking at the different traditional ducting styles, square ducting, despite being the easiest and cheapest to obtain in large quantities, is never ideal. Anytime you have square corners, you get friction within the air because one surface is moving at a different velocity to another surface, especially in the corner, meaning static pressure is higher, resulting in irregular airflow. In contrast, when ducting is rounded, there is far less friction, so air flows much more smoothly. The two rounded options are standard round ducting and spiral ducting. The cheaper of the two is standard round ducting, which is snapped together, enabling it to ship flatly in 5-foot sections with a channel. These sections are attached together, making a circle, which is done for every 5 feet until reaching the desired ducting length. Spiral ducting is available in 10-foot tubes and at a greater cost. Generally galvanized, it's sturdier, substantially stronger, and much heavier as a result. This structural stability lends itself much more easily to drilling air holes through without any denting or caving. If you're set on remaining within the realm of conventional ducting methods, we recommend going with spiral ducting because while more expensive, it's easier to work with and the longer sections look much nicer. When opting for any of these traditional ducting methods, making the specific calculations is important. On average, with a 5-ton air system, be it a standard unit that does 1800 to 2000 CFM, or especially an Evolution Series unit that is capable of up to 3400 CFM, about 15 or 20 feet of ducting is needed, with somewhere between 40 and 60 holes staggered on each side to adequately accommodate the air going through. How do you make this happen? You'll need to use a hole saw to cut and drill all these 3 to 4 inch holes. This often proves effective, but is not an easy task with a lot of hard work required to make it happen. It's time consuming, frustrating, and costly, and you're going to go through several hole saw blades. There are often a lot more holes needed than initially anticipated. Then you have to determine the correct number of air holes, an ideal register placement, because you want the same amount of air coming out the beginning of the duct as the very end, which also adequately manages consistent velocity and throw. What you're going to find is that a large majority of the air is going to come out the first half of the duct, with much less out the remainder. Countering this and sustaining even airflow means switching between different hole sizes, which are going to do different things. With that, you're getting into some significant engineering that you're probably not going to be doing by hand with a hole saw, further complicating the endeavor. Now that we've gone over ducting types, dispersion, flow rates, and velocity and depth, the importance of meticulous engineering has been established. If all those factors are not executed correctly, you won't get the result you're looking for. Here at XLR Systems, we approach the airflow design of a room with the mentality of the more evenly, the better. For that reason, we've taken the complexities out of the process, made the relevant calculations, and put everything together to totally bypass engineering and installation issues, develop a fantastic product, the fabric duct. With this innovative method, air is evenly distributed along the length of the room through an equal amount of laser-cut precision air holes on both sides, effectively acting as a sort of curtain and preventing hot and cold spots from forming within the space. As both our most popular add-on by far and a highly regarded product in their own right, fabric ducts are not only purchased alongside almost every system we sell, but are also used with other systems on the market. While some people's initial thoughts are the fabric ducts are more expensive, they're not properly factoring in the extensive costs of actually engineering, modifying, and installing traditional metal ducts. After doing so, it becomes apparent that the end costs are actually quite similar, having made growers' jobs substantially easier with an enormous increase in convenience and efficiency. Fabric ducts simply show up in a box and are ready to be installed in minutes by anyone, utilizing an aircraft cable, streamlining the entire process. From an engineering point of view, their lightweight composition negates any concern of load balance within a room, and they don't need to be insulated. Their machine washable, flame retardant material also does not condensate, so you're not introducing water droplets into your environment. We even have customers who keep an extra one on hand, allowing them to easily swap it out in minutes when needed for maintenance and cleaning. Fabric ducts are also totally customizable. You can put an elbow or multiple dispersion techniques while choosing which side of the duct the air is coming out, and we can specifically engineer their runs to be as long or short as needed. We aim to make our fabric ducts airflow as even as possible while deciding how far the air is to be thrown. If you have a single fabric duct in your grow room, it would ideally go to the center of the room right down the middle, throwing air at angles of 4 and 8 o'clock. With this configuration, the air hits the wall about halfway down, then comes back down towards the center. This results in a full span of about 25 feet, with 12 feet of throw from each side. If you don't have the space for that, such as if there is only a walkway at the doorway to the room, then you would have to hang the system to the side, at the edge of the room, to not be in the way of the lights, with the ducting coming all the way up against the wall, shooting out the one direction. In those scenarios, we would then assess the dimensions of the layout of the room to decide if those angles are still ideal for optimum performance. If you need the air to be thrown further, you're going to contemplate if a secondary system and duct can pick up the slack in that section. If you decide to run multiple systems in a space, it's important to make sure that their respective airstreams are throwing in such a way as to meet at some point for even dispersion at the canopy level. When adapting to specialized installations and their unique setups, anytime you have a tighter space such as intermodal shipping containers or high-density vertical farming techniques, gets even crazier on the engineering side. We're here to assist with all these challenges, such as in drying and curing rooms, where we're potentially dealing with multi-racks, baker's racks, hanging, screens, or mesh. The number one thing is that we don't want high-velocity air hitting the product, so it will dry the outside to a crisp while moisture remains trapped inside, which once bagged will result in moldy cannabis. How do we combat this? Taking product density into account, with the system adjusted to the drying techniques, ensures that sufficient airflow patterns are directed appropriately. Some of the designs require that the product be 1 or 2 feet off any outer wall, allowing us to send the duct around the perimeter, which will then blow straight down at 6 o'clock angle, using that perimeter gap as a lane for the air to then enter each rack from the side. Obviously, this medium velocity throw technique with traditional sonic flow wouldn't work in the middle of the room. So what do? We run a center duct with our innovative micro mesh, designed to have the same airflow and air turns, only at a fraction of the velocity, to rain the air down very slowly onto each level of the product before drawing to the return air. We always put the return air at floor level to force the air to descend through each rack as evenly as possible. The micro mesh ensures it will take its time drying to cure properly while keeping cannabinoids intact, resulting in a superior quality product. Again, airflow design is different for each space. There is no single solution, especially when talking about the differences between mother rooms, clone rooms, baby rooms, bloom rooms, veg rooms, and drying and curing rooms. In fact, even when the finished product is kept in a vault, if it's not in airtight sealed packaging, environmentally controlled airflow is needed. We've also known people that can't have stationary ducts, as their setups are comprised of movable racks. With so many variations, there are a lot of things to think about. Regardless of the method of dispersion and the manner of installation and the uniqueness of your facility, XLR Systems is here to ensure that your grow room is going to feel fantastic with optimal airflow, which will show in the quality and yield of your product. Our expertise in airflow design would not be possible without a comprehensive understanding of temperature, humidity, and air quality as they relate to sealed grow room applications.
When talking about temperature, there's an industry average that generally, if you can maintain 78 to 80 Fahrenheit throughout the day cycle, and perhaps 5 to 10 degrees cooler at night, this alone will get you most of the way. This is true to some extent, as most air conditioning is similar at face value. Just having some level of control will get you a good portion of the way, as you're already way further ahead than others who are simply opening their doors. Beyond that, there are many intricacies of temperature and how to utilize that. However, much like in relation to airflow, you can cool all the air you want, but if not being evenly dispersed throughout the room, you can't guarantee what's actually getting back to the system. That's where we really begin to see a fundamental difference with regard to temperature, as that whole balance dictates the type of cooling that you're going to get. Just as improper ductwork could shoot supply air directly back into the return air, making it even colder, incorrect thermostat placement could falsely indicate that a desired temperature has been achieved, when we don't actually know how well the air is mixing or not. Therefore, thermostat placement is very important, especially if your room is not evenly balanced. For instance, having the thermostat in a hot part of the room could keep the air conditioning running while the rest of the room is getting very cold, resulting in short cycling. Conversely, having it in a cold spot could prematurely shut off the system, even while the rest of the room is still very warm. Since thermostats have protective guards to avoid plugging and direct hits, other common issues is water, dirt, or debris preventing adequate airflow. Unsurprisingly, many of our technical issues revolve specifically around large temperature swings in a room and how to get airflow to the thermostat for faster temperature readings. We've also seen thermostats placed directly under light, causing them to read a much higher temperature, which is not an accurate average of the rest of the room. For these reasons, in an ideal room, rather than placing thermostats in the center where it's uncertain how much air is moving, we suggest under an oscillating fan or as close to the return air as possible, since that's going to read what's actually coming back to the system. That way, in a nicely balanced area where everything has been engineered correctly, the controller is operating off the system's accurate temperature reading. In terms of air conditioning, in order to run within a temperature of 70 to 80 Fahrenheit, a couple factors must be established. Most importantly, the units must be sized appropriately. Every ton of air conditioning equates to 12,000 BTUs. So for example, a 5-ton unit provides 60,000 BTUs, which can cool 15,000 watts. That includes burning CO2, as it is an additional heat load. When it comes to temperature, the insulation that you have in the walls, ceiling, and floor is going to dictate how much comes in and how much leaves. Our rating is based on R12 insulation or higher, as that's about as basic as it can be while still offering some protection. In terms of R value, with this level of insulation on drastically hot or cold weather days, extreme temperatures are going to want to permeate through, but the sealed room environment will be able to maintain itself without interference. While colder outdoor temperatures could be harmful at certain times, with your air conditioning systems not having to work as hard, nighttime temperatures could suddenly make things much too cold. With that in mind, what's clear is the more insulation, the better, as there are less variables to play with. On the other side of things, capacity must be considered. As we've previously mentioned, our rule of thumb that one 5-ton Evolution Series unit cools 15,000 watts of heat load and is based on an outdoor temperature between 80 and 85 Fahrenheit. Why do we specify the outdoor temperature? That's because we have a split system with an air-to-air heat exchange. As warm air from inside the room passes over the cooling coil, heat is absorbed into the refrigerant, which is then pumped via the compressor to the outdoor condenser. The condenser fan blows cooler ambient air over the hot coil to reject the heat, allowing the refrigerant to become chilled and pumped back indoors for another cycle. The warmer the air, the harder it is to cool down the refrigerant. The cooler the air, the easier it is. This has pros and cons. If the temperature rises above 85 Fahrenheit, we have to begin to derate the system. For instance, you're going to lose some capacity at 90 Fahrenheit, further capacity at 100 Fahrenheit, and significant capacity with anything warmer to the point where you're only going to get 50% capacity at 105 Fahrenheit. In those instances, in areas like California, Arizona, and Nevada, we look at reducing the capacity on those systems or dimming the wattage on the lights to make up the difference, so that in the worst case scenario, you still have enough cooling to get through. On the other side of that, for areas with colder climates, most people don't realize how important it is to have a mission-critical application like this in the middle of winter, opting to simply open windows instead. Unfortunately, that doesn't work well. These plants don't like drastic cold temperatures, so for instance, if it's negative 30 outside, doing this would freeze and kill them. Even with less extreme climates, opening your grow room up to moisture, content, and pathogens is not a viable option, so you need to remain sealed. A major problem with traditional air conditioning equipment is that it generally does not work well below 50 Fahrenheit outdoor air. While the condenser turns on, the fan goes into high speed and overcools itself to the point where it starts to freeze and seize up. In contrast, all of our Evolution Series units come with low ambient fan controls and a special thermistor that allows them to manage fan settings in conjunction with outdoor temperatures. So on extremely cold days, this turns the fan completely off. In fact, last winter, during a flash freeze cold spell in Alberta, one of our Evolution Series units ran without issues for 2 weeks in temperatures of negative 35. By taking these factors into consideration and sizing systems appropriately, we ensure that you can maintain virtually the same capacity all year long, regardless of what's happening outside. Then looking at the night cycle, we've had some customers who have really wanted to bring temperatures down, especially in the final couple weeks, for plant color and hardness factors. While this is possible for the plants themselves from purely an air conditioning and dehumidification related standpoint, if you have temperatures below 65 Fahrenheit, you run the risk of freezing the system. You may be wondering how we actually set and control the temperature. Every one of our Evolution Series units comes equipped with an i3 Wi-Fi compatible thermostat that allows you to set different programs and monitor multiple systems with ease, all from your mobile device. You can ensure constant temperature and conveniently toggle between air conditioning and mass dehumidification modes, because temperature is never possible without humidity. Additionally, for facilities that want to integrate large customized controller systems, all of our systems can be easily integrated by using a dry set of contacts. Humidity. We've encountered many individuals who say that they can't keep up with humidity, but the first thing that they have to understand about humidity is that it's much like the reverse. It's also never possible without temperature control. We like to refer to this direct correlation as relative humidity, RH, because it's relative to the temperature and can go up or down accordingly depending on the amount of moisture in the space. An easy way to comprehend this is by thinking of a room as a sponge that is larger with warmer air and smaller with cooler air. If you took this large sponge and dipped it into a bowl of water, it holds itself in a warm room. But as the temperature falls, the sponge is squeezed and can't hold as much, so water comes out. For instance, if your room is at 80 Fahrenheit, you are running at 55% humidity, and you cut the lights after 12 hours. Your temperature is going to drop dramatically, which means your humidity level is going to rise rapidly. As the air gets warmer, it expands and can't hold more moisture, but as it gets colder, it contracts and can't hold as much. Even with the same physical amount of moisture in the air, at 80 Fahrenheit, it might be 55% humidity, while at 60 Fahrenheit, it might be 75% humidity. The only way to get around this discrepancy is to implement adequate dehumidification, which is not going to happen instantly, so there are several things that we have to take into account. In the average grow room, with air conditioning that's sized appropriately, keeping the temperature rather precisely between 78 and 80 Fahrenheit with humidity levels between 50 and 60% is ideal. Air conditioning in general has to dehumidify before it can actually lower the temperature, which is done by lowering the dew point, which then in turn drops humidity. Therefore, anytime you're running air conditioning, you are dehumidifying, as the process itself takes moisture from the air with condensation forming as warm air passes over the cold coil. While a grow room's day cycle is usually fine, as noted, the night cycle can cause issues if set up improperly. During the night cycle, lights and air conditioning are off, but the same amount of moisture is still sitting there, and if it reaches 70%, the risk of mold and mildew spirals out of control. Dehumidification is needed, but the challenge has always been obtaining units large enough to adequately accommodate this kind of setup. How does Excel Air Systems combat this? Well, we find that the average 15 light space at full bloom is going to transpire roughly 50 gallons worth of water per day for moisture. Why is that important? Because our systems are designed to remove 50 gallons, 400 pints of moisture each day, perfectly countering this. That being said, cultivators who feed plants more on different days have to look at not just what's being fed on one particular day, but what the average is across multiple days, and the other nutrients aside from water have to be taken into account. If you're feeding plants 100 gallons, not all of that is going to be vapor. Each is going to saturate differently depending on the type of growing medium. We consider these factors for both the day and night cycles in order to size dehumidifiers properly and maintain balance. Growing robust plants for higher yields with 2 pounds or more per 1,000 watts requires a significant amount of dehumidification. When doing this, dehumidifiers direct heat from the motor back into the environment through a process called heated compression. This entails having a compressor running and knowing how much the refrigerant is going to take. If you have 4 or 5 of the dehumidifiers running, they could be throwing an extra 10,000 watts or more into that environment. This means that the room temperature is going up, which hits the threshold on the thermostat, turning the air conditioner on to restore the cooler nighttime temperature. Then as it turns off, the temperature rises again, making the air conditioner turn back on again. At this point, what's happening is that your air conditioner is fighting your dehumidifier, which is not very efficient. On top of that, most dehumidifiers have a freeze and thaw cycle, as they extract the greatest amount of moisture by running as close as possible to freezing. They often do end up freezing the system. When this inevitably happens, they either require hot gas to thaw, or the system just turns off for a certain time duration, usually around 15 minutes, before starting the process all over again and repeating the cycle. Anytime the system is in the process of going from freezing to thawing, it's not dehumidifying, so you are losing time. Where does Excel Air Systems come in? We offer the Evolution series, which not only conditions the air but also mass dehumidifies, which it does perpetually 24 hours a day without shutting down, allowing for more condensation to be extracted from the environment. There's never any battle between air conditioning and dehumidifying, nor is there any freeze and thaw cycle, as the Evolution series heats the environment in dehumidification mode, efficiently switches into air conditioning mode, and drops the temperature, then flips back into dehumidification mode again. It's designed to do this on the fly without any issues. We can stagger systems, so that, for example, if there are multiple systems in a room, 3 of the systems can be designated with one set point, while the 4th system can have a different set point. We can stage up, we can stage down, there's a lot more versatility, and with that dialed in, it doesn't matter what else is happening, whether your insulation isn't strong on a warm day or the temperature is slowly increasing from the emanating heat coming in, because our Evolution series system is going to run. You can rest assured that it is mass dehumidifying while in air conditioning mode, because that's just what needs to happen. Then when it flips into dehumidification mode, that's fine too. We're just simplifying that process. As for the moisture that is recovered, many people reuse it by putting it back into their reservoirs. In desert climates that are running 10% humidity outside, grow room environments, which may not be super tightly sealed, might be running at very low humidity, as the air conditioning is running to keep up the temperatures rather than maintaining a humidity level between 50 and 60%. They may be running between 30 and 40% instead, which is too low for most plant strains. That's where a product like the Cloudmaker humidification system, our new upcoming product will be launching very soon, will prove effective at offsetting that with additional humidity. Designed for 69 gallons of water, 550 pints per day, it's more than enough to compensate for one 5-ton system, so there's no worry about losing that battle where the humidity is getting too low. The Cloudmaker will also be ideal for helping plants thrive during their early stages when they aren't big enough to transpire. We have a lot more information that we need to go over regarding extraction per plant that we are more than happy to share. So feel free to reach out to us and we can go over that in greater detail while making the relevant calculations. Additionally, for both humidity and temperature, there are professional level designs that we can institute. Many growers have analytic controllers that allow them to see what's happening, and some of them have come to us with this data to ask for assistance in taking some of the stress out of the transition between day and night cycles. Just as temperatures increase when lights turn on and decrease when they turn off, humidity does the same, only the inverse from day to night. There are ways to smooth that curve, such as the sunrise technique, where half hour or hour before turning on the lights, we already start to bring the temperatures up a degree or 2. That way, there's not going to be an instant pop when the lights come on. Similarly, with the sunset technique, to prevent the spikes in humidity at night, we start to decrease the temperature near the end of the day, removing the excess in humidity and lessening that impact. Really, we're just rolling out the points on the data chart to smooth them rather than having such radical spikes. These techniques go a long way in helping plants be as good as they can be because they're not shocked by a drastic contrast of on and off. We can also look into each individual cycle, specifically comparing plants in the first week of their bloom cycle to those in their 8th week, to best manage temperatures when they are transpiring differently, running either higher or lower to help mitigate the effect. The concept becomes fairly intricate when factoring in vapor pressure deficit, VPD, by looking at the leaves to determine how well they are transpiring or digesting. While we know that on average, VPD runs a higher humidity level, it's critical to still have proper analytics in place for specific adjustments because you're walking a very fine line, and a product like the Cloudmaker will be required to make this work. As you'll see from the VPD chart of temperature and humidity, within the green area is what many botanists recommend, having found it to be the perfect sweet spot. At Excel Air Systems, we think that it needs to be done a bit differently for cannabis, but recognize and respect that each grower is going to have their own opinion based on their own experiences, and we can certainly work with VPD controls. Doing so just requires more analytics and proper sensors in place to know exactly what's happening in the room. Having proper air conditioning and humidification systems is a must, as it's a very fine line, but we can certainly help with that. We've also occasionally had customers who want to exhaust fresh oxygen into the room during the night cycle to counter a buildup of CO2. Sealed rooms generally tend to balance oxygen levels with CO2 consumptions quite well, but as long as it's a small amount that is specifically targeted, exhausting at night will certainly not hurt the environment. Since we are deliberately quite methodical about exactly how many air turns is needed, timers and fans could be utilized to execute this strategy, as we don't just want to open clear air exhausting into the room for prolonged intervals. That being said, exhausting is certainly not required, as what matters more than additional oxygen is simply the quality of the air itself. Air quality. What does air quality mean in relation to sealed rooms? Air quality factors in several key aspects of implementing sealed room technology, most notably the importance of air filtration to remove particles, dirt, and debris that might be floating throughout the space. All of our systems include a built-in filter, which, while lending itself to additional features, is predominantly designed to protect the system itself. Regularly changing the filter is necessary for both the efficiency of the system and to capture as much as we can within that space. As an additional line of defense against airborne particles and volatile organic compounds, we offer the clean air filtration system, available as either an inline addition or standalone unit. Fitted with multiple pleated filters, including a pre-filter and secondary high-efficiency filter, the clean air filtration system is designed to effectively scrub the air of harmful particulate substances down to clean room-grade micron levels. Furthermore, while many growers do enjoy the natural scent of their organic product, many employees and members of the community do not. For that reason, the clean air filtration system also uses multiple trays of custom blended coconut carbon to mitigate odors within a facility, creating a better environment for workers and keeping within municipality regulations to avoid unwelcome attention. This coconut carbon charcoal is not pelletized, but shaled, like when smashing a rock with a hammer. This method results in an assortment of similar sized pieces without any one piece being the same, in contrast to the identical pelletized pieces that you generally find on the market. What makes this distinction so important? Pelletized pieces allow air transfer to happen more evenly, but following the path of least resistance, where shale has no singular path that air moves through. This means greater longevity, since every few months you can literally just pull the trays out, flip, dump, and mix them around, and then put them back in for continued use, because there's new surface area that wasn't there previously. Additionally, while it can be difficult to fathom due to the charcoal's crevices, pits, and oxygen pockets, which observed under a microscope resemble miniaturized caverns, only a small handful of coconut carbon shale has the surface area of a football field. When it comes to air filtration, the more surface area, the better. So a 55-pound bag of carbon charcoal provides a great deal of continued odor removal. While coconut carbon's many attributes lend themselves extremely successfully to organic compounds, especially harsh cannabis smells, they are less effective with chemical compounds. Therefore, if necessary, we also offer zeolite, renowned for its extremely absorbent properties to reduce odors from fuel, paint fumes, and smoke. Rather than simply selecting one or the other, this gives us the ability to potentially provide custom mixtures to combat different combinations of smells that your facility is emitting. After the highly effective particulate removal and odor removal stages, Excel Air Systems offers a third stage, UV purification, to kill pathogens, as these harmful organisms thrive on replicating themselves, which lead to powdery mildews and bacteria. We use a germicidal band of UV light called UVC, achieved by operating at precisely 254 nanometers in the UV light wavelength. Why is that so important? Being outside of that band does not achieve the desired properties of UVC, and could potentially get into the UVA or UVB instead, which would be totally ineffective at best and very harmful at worst. There are a variety of UV purification units available, but only a select few can maintain the 254 nanometer standard that the Excel UV air purifier guarantees. Regardless of temperature changes with our dual shielded bulb, by insulating our bulbs and placing them in the supply air chamber, they're not seeing those temperature swings. So we know that they're always targeting pathogens. How does the UV air purifier function? Around each bulb, there is a 3 to 4 inch kill zone, so any air within that will get hit. When beamed with this light, pathogens are not just being temporarily fried, but actually having their reproductive ability totally destroyed. Now unable to repopulate, they fall to the facility floor to be swept up and discarded. As the bulbs are fairly small, some would argue that they are not as good as larger ones with a higher contact time. This would be true if the outside air was only coming in once for a single pass, but we've designed it for sealed rooms, where the air is going past the bulb every 1 to 3 minutes. As pathogens like mildew can live up to 10 minutes, we've already had at least 3 shots at sterilizing that, with so many more air turns in that time. One of the coolest things about the UV air purifier is that it can be incorporated into any system, as long as it's running at 24 volts. It can be easily connected to any air handler via the same relay, allowing it to operate concurrently with the blower. In other words, anytime the fan is on, the UV is running. Our UV air purifier also has a guaranteed 2-year runtime, so that's 24 hours a day, every day for 2 years straight. Altogether, our mastery of air quality, humidity, and temperature control really comes down to providing your facility with a foundation of consistency on which to build a platform of understanding so that you can run controlled experiments. In doing so, you can refine the process for continual improvement, enabling opportunity for bigger, better, higher quality yields in the future.
The future. Our perspective on the future is molded by taking a peek around the corner at unique upcoming developments that could truly be transformational within the industry. From a scientific standpoint, what we're observing is incredibly mind-blowing, as cultivators are starting to be able to take different varieties and strains, look at cannabinoids at a micro level, and assess which characteristics applies, from THCA through THCZ. For instance, in terms of cannabis production, if you're a sleep company and only want to sell THC-based sleeping pills, or if you want to develop products targeting sleep, hunger, or other different ailments, you need to have the ability to grow different strains that are heavy in those types of cannabinoids and extract only those specific, rather than current methods, which are much more holistic. This concept is unbelievably cool, but this is only really possible at a high level with the components for total environmental control in place. With that, if a light is operating at a certain type of wavelength or an exact temperature, and it results in more of a particular cannabinoid, you know what configuration you've implemented to achieve this. These techniques are currently in early stages, but they represent huge potential for opportunity to produce certain strains for very specific markets. Then, getting beyond the actual growing of plants, we're also observing similar prospects in the field of synthetic production. This means either working at a cell-by-cell basis or a completely synthetic level where there's no actual plant material involved. These fascinating ideas are among a myriad of possibilities that are currently coming down the pipe. We're very interested in learning more about all of them in order to assist in the expansion of innovation. The major underlying factor when creating new plant strains and cannabis products is utilizing analytics to identify factors that directly affect development and managing them to your advantage. The cannabis industry has begun to enter the era of big data, where all this information regarding temperature, humidity, soils, nutrient levels, air velocity, and lights is being collected and brought together in one mass stream data collection. These data points are being layered for an in-depth usage in uniquely complex ways, to the point where repeatable tests drive the quality of yield much higher. This then allows producers to determine recipes not unlike in a cookbook, with exact configurations for hundreds of variants, entirely based on metrics. Knowing how to get a specific strain or an exact amount of THC content using certain lighting with a certain system and how that integrates with other elements of the growing process means limitless possibilities. Analytics is definitely what opens the door to the adventure. But that information is only useful if it's put into something novel and unique. Recognizing the importance of this, XLR Systems is heavily investing in these concepts. We are going to be launching a data analytics controller in early 2021, which will be the start of a new era for us, with a major shift from the physical world to the data-driven software world. At XLR Systems, we don't look backwards for very long, so we're passionately interested in all the abilities that you can unlock with our innovative data-driven technology and methodology.
In closing, reflecting on everything we've covered across this webinar within each room, all of these unique characteristics layer and intermix for consistent end results and superior products. If you were to take only one thing away from today's session, we'd hope that it's the understanding that Excel Air Systems has the knowledge, expertise, resources, and equipment that you need to successfully create the most consistent environment possible, which will allow you to level up and set new standards in high-quality cannabis production. That being said, there's obviously still a tremendous amount of additional information which we are happy to provide you with, because we recognize that everybody's circumstances and situations are unique. An integral component of our inclusive services is bringing your vision to life through our 3D digital room designs, which are completely free as part of our consulting process. All that we initially require from you is that you fill out our online snapshot form. By answering those simple questions, you provide us the information we need to embark on the path of making your dream a reality. On that note, we are looking forward to part 3 of the Sealed Rooms webinar, where we can further elaborate on the intricacies of sealed room technology and uncover some important lesser known points of operating a profitable business. You're not going to want to miss this one. We will be sending you more information on that webinar at a later date, but right now we'd like to be respectful of everyone's time and express our sincere appreciation to you for your continued interest and attention. Thank you for giving us the opportunity to share more of our knowledge with you. It's been enjoyable. Please feel free to reach out at your earliest convenience and send us an email with any questions that you may have. Or as we mentioned, visit www.excelAirSystems.com/snapshot to fill out your snapshot form so that we can gain a better understanding of your situation to help you better.